Hi, this is Daniel from TrustGraph, and today we're on the part two of our series of engineering thoughts on the why behind the design decisions of TrustGraph. We've already talked about system reliability a little bit. Now let's go in a slightly different direction and talk about network topologies. Probably thinking, network topologies? Why are we talking about network topologies? Well, hope all will be clear. Maybe not in this episode, but in the next. I know we're going to do a little bit of a teaser with this one. So there are many network topologies. I've just chosen a few of the most well known to kind of talk about. And the first one I talk about is point to point. Also, you might hear a variation of this called, tree hierarchical. The way I think about this one, and this is actually the way I think about a lot of these network topologies, and as we get increasingly more complex, this way of thinking becomes more difficult. I tend to like to think about them as how I would actually wire them together physically, because that's how we used to create networks. Now, with software complexity where it is and cloud infrastructure, it's a little bit more challenging to use that analogy. But for point to point and tree architectures, I like to think about how these processing services would be some sort of physical device that you would have wires going to. I could physically have one wire connecting each one. So it's relatively pretty easy to visualize. And in a lot of ways, when you're making API connections, it's a little bit like this, how you're wiring them together. Or a lot of times in the workflow builders that are popular today, when you have these blocks, React Flow, for instance, is a very common UI builder. Or excuse me, well, it's a common UI for wiring infrastructure and code together. You wire them together very much like this. So I think everybody understands this one pretty well. Ring architectures. So as you can see, this is also another common type of network topology. And again, we have these components that are wired together in a very series fashion, so that if one of these connections between two of these components fails, well, the entire system fails. And again, that's somewhat like, point to point networks too. If one wire fails in between one of these systems, excuse me, one of these modules, the entire system is likely not going to be able to continue to operate. Same thing with ring architectures. If any connection between these modules in the ring fails, then the entire system fails. Star networks. Now, this is actually a much more realistic way of thinking of an API service, because API is this central processing hub. You have this service that lives somewhere, you send a request and it sends a response. And many people are doing the same thing. So Star Network is a way of thinking about API services like this. And again, as we talked about in the last episode, this is very much a monolithic architecture in that this central processing service, or the API, is the total source of reliability for this system. Well, not entirely, but it's the single point of failure. If this central processing service fails, then all of the connecting services won't be able to operate. Now, of course, there can be individual failures in between the consumers of the central processing service. But in this architecture, that central hub or the API service has to be as reliable as possible. Now we're getting a little bit more complex now. Bus architectures. This one is, we're getting a little bit closer to where I want to go with this. In some ways, bus architectures are quite old and are more common on hardware systems. But bus architectures, when it comes to their complexity and low performance, well, latency, well, I shouldn't say necessary latency, but you can look at this architecture and probably guess that this isn't going to be a super high throughput network topology. The way a bus architecture like the one I've drawn works is that you have a bus controller. So any one of these services kind of has to raise its hand and say, I want to speak to processing, I'm processing service one, I want to speak to processing service seven. And the bus controller will basically route that request, which means the bus controller kind of has to clear the bus to allow this communication to take place. The bus monitor can be there, is often optional in these topologies, and it can be there just for reliability purposes to understand what's going on the bus. But as you can imagine, there are advantages to this. It's very scalable, highly scalable, because once you have this bus, which is often an actual physical rail in a system, if you think of a hardware system, you just plug into that rail and you're good to go. You can communicate with anybody on the network, which of course, in the previous network topologies, whether it's point to point, whether it's a ring, whether it's a star, for one service to be able to communicate with another service on the network, you would have to build a physical connection. You don't have to do that here, which makes scaling up very, very simple. But of course, there are drawbacks in that you're dependent on this bus controller to control the data flow on the bus. Mesh networks. No, I didn't. I didn't draw one of these myself because, well, mesh networks. I thought, well, we're really ramping up the complexity here. So in mesh networks, basically every device on the network is interconnected in that device one can connect to device two, device three, etc. And how this is accomplished can be, quite complex. I think wireless networks are often the easiest way to visualize this because it becomes very tricky if you think like, how do I wire all these things together? Is that really possible? But in wireless networks, it kind of makes a little bit more sense. But this again is a very popular way that devices are networked together now, and quite a bit more complex. And that brings us to the topic I really want to talk about, and that's publish subscribe. Why do we talk about publish subscribe nodes or pub sub? It's because TrustGraph is built on top of Apache Pulsar, which is a pub sub networking topology. Now, when we look at this diagram, it makes publish subscribe look really simple. Unfortunately, it's not that simple, especially from a metaphor of wiring things together. That metaphor really doesn't hold at all for publish subscribe. Now, PubSub is not new. There are standards for PubSub that go all the way back to the 90s. DDS, for instance, which is used a lot in real-time applications. In IoT, you have MQTT. And of course, for cloud, you had Kafka, and now you have Pulsar. And conceptually, they're the same in that you create topics and you publish those topics, and then you have subscribers to that topic. I think the metaphor that I'm going to use is actually it's the best way to understand PubSub is to actually think about social media, believe it or not. And PubSub actually becomes a bit of a hybrid of bus, mesh, and star in a lot of ways. Because the way you connect to it, it kind of seems like a star, but the way it scales, it's a bit like a bus, but everything's kind of interconnected too, all in this one backbone. And that's why it's so powerful. But that's also why it can be difficult to really wrap your head around at times. And that's why in our next episode, we're going to dive much more into the fundamentals of PubSub, why we chose it, and why that matters.